Let us attempt to summarize what we've learned during this particular section. We started with critical sections which use the lock keyword, and typically we saw that locks operate on an existing object, so you just make an ordinary object and that's what you use as your kind of padlock. And really a lock keyword is just a shorthand for monitor.enter and monitor.exit with the appropriate try finally structure. Now the idea is that this thing blocks until a lock is actually available, unless of course you use one of the overloads. So if you decide to avoid using the lock keyword and instead go for something like monitor.try_enter, then you can specify a timeout value and you can essentially jump out of the execution of that area, that critical section, if the timeout has in fact elapsed. Next up, we looked at some lock-free programming with interlocked operations. These are useful for automatically changes, or atomically rather, changing the low-level primitives like integers. For example, we saw that there is an interlocked increment decrement for a counter type variable if you want one. There is interlocked add, which we used for changing the bank account for depositing and withdrawing money, and then we looked at exchange and compare exchange. Then we talked about spin locking and lock recursion as well. So spin locking is basically a kind of lock which, when it's waiting, it doesn't yield control, it doesn't allow the scheduler to schedule another thread and then reschedule this one when you do in fact get the lock. So a spin lock basically wastes CPU cycles without yielding. On the other hand, since you're avoiding context switches, it is useful for brief pauses to prevent rescheduling, but you shouldn't really keep a spin lock for too long. Now you use enter to take the lock and then exit to release if it was taken successfully. Once again, remember that we checked whether the lock was in fact acquired. The lock recursion paradigm that we looked at is basically the ability to enter the same lock twice on the same thread. So if you call enter twice on a spin lock, for example, you would get an exception because spin lock does not support lock recursion, but other constructs do. And we also saw that there is something called owner tracking, which helps the spin lock keep a record of the thread that acquired the lock, such that if you try to do lock recursion with tracking, you would get an exception, and you can catch this exception and process it. However, without lock tracking, you would just get a deadlock on the spin lock. So then we looked at the mutex type, and that's essentially a wait handle derived synchronization primitive. We used the wait1 method to acquire a lock. So essentially, to kind of get into the mutex, there is a timeout parameter there that you can specify to sort of wait upon if you want to only wait for a specific time for the mutex to become available. There is a release mutex method to release the mutex, obviously. We also saw mutex.waitAll to acquire several mutexes at the same time, so to wait for all of them to become available. And finally, we saw this idea of a global or named mutex, which is actually shared across different processes. And then if you've made a mutex, you can say mutex.openExisting to acquire the mutex. And if you obviously haven't got one, then you can just make a new one by calling new mutex, but the second argument is the one where you provide the name, thereby kind of indicating that it is going to be a global construct. And finally, we looked at reader-writer lock. So it's essentially a lock that can be used to lock for reading or for writing. So it's a kind of fine-tuning approach to locking. This construct does in fact support lock recursion as a constructor parameter, but once again, I would not recommend using lock recursion unless you absolutely have to, because it can be a nightmare to figure out what's going on later on as you kind of get involved in the very complicated kind of invocations of the construct. So it does support this idea of upgradability as well, which means that if you want to take a read lock but think that you might need a write lock, then what you can do instead is you can enter an upgradable read lock, and subsequently you can upgrade it by entering a write lock. So that's our introductory foray into synchronization.